David, hey, thanks for joining us, man. I know you've been here before, but for everybody else, welcome to Defender Fridays. You know the name of the game. Coming together with a bunch of awesome people, hanging out for 30 minutes just to talk about things defensive in general, infosec as a whole. We've got David Burkett on, who's been working on something super cool. Our team sort of has had some visibility into this project of his, but the topic is a really interesting one, and it's something I actually recently blogged about. It's essentially fuzzy hashing, right? And I'll just give a really quick blurb, David, but I'm going to let you do your thing. But
Yeah.
fuzzy hashing, I know probably familiar concept to most of the folks on this call, but I would not be surprised if there's at least a handful of you that are like, "What is a fuzzy hash?" Right? And it's this idea of leveraging um, more resilient indicators in threat hunting, detection, and all that good stuff. And what I mean by that is, indicators, things like IP addresses and domain names and things like that, we all kind of know and love for their different uses. Well, I should say we love and hate, right, for the various reasons. But resilience in indicators is also pretty important because most of you also know a lot of these indicators are pretty much disposable, right? They got a shelf life of half an hour. I mean, they're just not super useful for the long term. And file hashes are a huge one of those. Like these are probably among the most disposable. Because usually when we're hashing things, it's stuff like malware. And the problem with most of the hashes that we're familiar with, they're static hashes, right? MD5 and SHA-1 and 256 and all these. Meaning, if anything about that file changes, that hash becomes unrecognizably different. And great, that old hash is no longer useful. And so fuzzy hashing has been around for a little while, and it's the concept of, hey, instead of like hashing, bit by bit this file, let's take a more sort of what's the right way to say this? Kind of a more resilient approach to hashing bits and pieces of it in a way that even if certain small pieces of the file change, the whole hash doesn't change. Maybe just a portion of the hash, and so you can still rate files by similarities, which is super useful. And there's a lot of these fuzzy hashing algorithms out there. One of my favorites is the MPash, which was brought about by Mandiant many years ago as a way of looking at portable executable import address tables effectively, right? So it meant that I could take an MPash of a piece of malware and follow that malware through its life, even if its SHA-256 or MD5 is changing. I can also potentially find other malware samples in that family, which is super cool. But David's coming on today to talk about another fuzzy hashing algorithm called TLSH. David, kick it off, man. What is TLSH and why should we care?
Yeah, well, actually, before I talk TLSH, there's something else kind of like Impash for Linux binaries that I didn't know existed until I guess had a parallel thought and then found a better implementation of what I made. But it's called TELF hashing. Same thing for Linux binaries. It's already built in the virus total. You can use it today. But yeah, it's a TELF hash. TLSH, Trend Micro Local Sensitivity Hashing. I see Jeff McJunkin, thank you, kind sir, has put a lot of documentation into the chat around where you can find some of the information about it. But basically, the way that it works at kind of a high level is it takes two binaries and it looks at how similar they are through different I guess you could say kind of mathematical kind of factors. So it groups different binary like parts into chunks, and then it kind of compares the two, and then gives you a distance score. The lower the distance score, the closer in similarity they are. So a distance score of 0 means two binaries are exactly the same, whereas the further higher you get, the exponentially more different that it gets. So that's kind of the high level version. And one of the things that I really wanted to do with TLSH hashing. So it's one of as I've been a security analyst, which has been a surprisingly long time now, I've been noticing,
Creeps
is
up on you.
yeah, it really does. There's been a lot of tools that have had like fuzzy hashing features available, like maybe they calculated the SSD or even the TLSH hash. But I've never really had tools or ways to make use of that personally for detection or hunting that wasn't building kind of ad hoc stuff. And I never really heard many people talk about like how they used it for just detection and stuff. So I wanted to um, basically do some things myself to make fuzzy hashing in general just more available to I guess the wider security community. So one of the things that I've done is I actually built a tool that monitors uh, something like a gosh 70, 80 open source attack tools and calculates the TLSH fuzzy hashes for all of the different commits. And I make that all public just so that anybody can use that data for free for their own detection. But yeah, it's one of those things that I think is super underutilized for detection. There's a lot of cool stuff that you can do that's not even like straight like detection related where like I see a binary and I see this that you can do with it. So yeah, it's a really
David, you glossed over that one kind of quickly, but I don't want to drop that. What's the project that you just discussed, you just mentioned on GitHub that you put together?
yeah. If you go to the Magonia Research GitHub page, there is a detection content I guess, repo in there.
Okay,
And
got it.
yeah, I can drop that in there. And if you see there's IOCs and TLSH,
Love
and
it.
yeah, a huge list of open source tools that uh, give you both, well, also the SHA-256 hash, not ideal, but the TLSH hash. One of the actually funny things is I was building some tools to like do some comparisons of like my tool hashes, and I would, pick a binary from GitHub in the releases section, and then I was just running it and comparing it against a big list of those hashes. Like, why can I never get a zero, like a perfect match? Like, I know this hash is in here. Like, is there a bug in like the way I'm calculating it or something? And it's just because I was always hitting a hash before the one that I got to. Like, I would get a certain version and it would hit a match on an earlier version's hash uh
Mm.
distance score. I don't know. This is a kind of a funny.
Let me do a brief impassioned argument for fuzzy hashing from the perspective from my perspective as an attacker.
Yeah.
Um, Application control, sometimes known as application whitelisting, right? Instead of having the infinite universe of possible binaries, you're trying to limit them out. But just allowing Microsoft signed binaries, even with some exceptions, is not good enough because Microsoft has plenty of binaries that allow for arbitrary code execution. One of the easiest examples is MS Build. So you might say, okay, well, let's allow Microsoft signed things, but block MS Build specifically. Well, this is where if you're blocking by file hash, it turns out that for authenticode signatures, they're not parsing all of the binary itself. So you can absolutely have a binary that has the same functionality as MS Build and is still validly signed by Microsoft with the same authenticode signature, and yet doesn't have the same resulting file hash as the original MS Build. If there is a new Microsoft signed binary inside your environment, it will run. If you chose otherwise, you'd be breaking every machine every month. So if there's a new Microsoft signed binary, it will run. Something like fuzzy hashing will get you when somebody is changing a pre-existing binary to try to hide amongst the fact that it's Microsoft signed. Fuzzy hashing is something you need.
Yeah, yeah. So, and also just by the nature of a lot of attack tools, whenever you're specifying like IP addresses, domain names, whatever it might be, that changes the hash of the binary. And that's one of those things that's just a real easy catch. So some things that used to make a hash very specific to an organization, all of a sudden don't really matter anymore. You can still detect them because the binary is ultimately uh, structurally similar.
Yeah, as an attacker, it's easy to get lazy and do mostly the same binary and have a trivial change so it's a new file hash or the new IP or domain to phone home to. And at that point, the fuzzy hash will be 90+% the same. That's good enough to match upon, especially for threat hunting, right? This is in, correct me if I'm wrong, but generally speaking, you would not want to block by fuzzy hash. You want it to be a detective control that there's a human in the loop for taking some kind of reaction to it.
Yeah, exactly. So one of the things you'll see too is there's a whole table that the TLSH group or like has put out, so you can kind of get an idea of the false positives ratios you might see. Keep in mind too that you'll want to go lower and just think about how many binaries you might go through in your organization and how maybe 1% can kind of add up a little quickly. So just keep that in mind whenever you're building it. But yeah, it's something that's super useful for that.
To double on that, we can quibble about the percentage, but just humans, if the majority of what they encounter is a false positive, that you have the threshold so low that the vast majority of things matching the fuzzy hash to a 50% margin or whatever is not actually matching malicious, then humans are like humans at the TSA. If the vast majority of the time it's a false positive, they'll assume everything is a false positive. So it's not just about how much time they have, it's optimizing for human psychology involved too.
Yeah. And one of the
Alert
things,
fatigue. John, you're absolutely right.
yeah, and one of the things that I really hope that expanding the use of fuzzy hashing does is it really, my hope is that it will force attackers to do things like use packers or use heavier obfuscation, which then in itself can become a detection opportunity. So like just by, making some of this stuff harder for them, it kind of raises that bar, makes things, gives you more potential detectors, even if the fuzzy hash doesn't make sense. Maybe you're catching that evasion technique.
Love it, man. So David, how does a team that's just kind of getting their arms around this, how do they start to operationalize this at scale, right? Because I don't think we're getting any fuzzy hashes from any native telemetry, right? Like Windows event logs, Linux syslogs or anything like that. And I know that you can get one step closer with Sysmon, right? And Sysmon will generate imp hashes for portable executables that are run on the box. But like, I don't know, how do we get closer? You have any tips or
Yeah.
tricks?
Yeah. So there's a lot of tools that will do it natively. Most EDRs will calculate the imp hash. They don't necessarily open up a way for you to do something with that imp hash, or not imp hash, sorry, TLSH hash. So like it makes it available for you. So you typically have to kind of glue it together. And what I've seen in the past and what I've had to do in the past myself is I've used things like Jupyter notebooks or just build my own automations to then go through and say, hey, here's my hash list that I want to reference. I'm going to go through query my SIM or maybe my EDR logs, pull all of the TLSH hashes I've seen, and then do that distance comparison myself. And you have to really build that out yourself. But you don't also have to use it in that manner for detection. So another cool thing that I like about TLSH hashing is using it to find other binaries just to look for maybe different versions of it. So a good example is there was a some Linux malware not too long ago, and I think I posted this in the Intel chat in the Leamy Charlie channel. But the long story short, the write up on it was awesome by the company. I don't remember who did it, but they said they found like the earliest version going back to 2022. I plugged in the TLSH hash into VirusTotal and found one that was 80% similar that ultimately was the same binary that had 0 detections. Meanwhile, only the hashes that were in that report had like 30 plus, of the vendors detecting it. Same version. It was out a year. It looked like they were just working on it at that point.
Oh,
But there were no detections on it. So it can be used not only for detection and like a live, like, hey, I'm going to compare every hash in my environment, but I want to look to see if there's any other maybe similar ones that have no detections and then see what they're doing different, build that YARA rule, see if they have some different behaviors for Sigma rules, that kind of a thing.
all day, man. So I could already think of a million awesome use cases for this, but like one that comes to mind is, when you're triaging a box that's in scope of an intrusion, right?
Mhm.
And you're gathering all your evidence and all that good stuff. Something that could make sense is, oftentimes there's like the obvious thing. You're like, okay, we found the malware. It's sitting in C Windows temp and it's running on a scheduled task. Okay, got it. Well, how do we know that there's not like another copy of that or something similar somewhere else, right? And this where something like TLSH could really come into handy because it can do that distance comparison, right? So I can hash every file out of that box, and then just simply show me in order of the closest matches, right? Whereas even an imp hash is not really that useful in this situation. It could be, but it could also not be, right? Because what if it's not a portable executable, right? Like that I'm looking for, right? So the TLSH I think is a little bit more robust in that way.
Yeah. Let me give you a good example. So Target actually wrote about this and how they use TLSH hashing, but Target has built an open source tool called Strelka. If you're not familiar with it, it's amazing. I used to love using that. But the idea is Strelka is just monitoring all the Zeek files output. So Zeek is a network security monitoring tool, carves all of the files off the network live, and then Strelka just slurps those files up, shoots them over to be scanned, gets all kinds of metadata to it. But the cool thing about it is if you get Strelka type style data and you're looking for like a red team or someone that's pivoting across your network, and you're able to go through and query against the TLSH hash, and then you can now look for maybe where they've moved laterally and the binary is different, like you said, and then see, other potential things just throughout like however long back of data that you have. So maybe you didn't detect an earlier version or, some stuff that they've done since.
It's also great for attackers that you can scan your binaries before you send them to your victims to make sure that you're not being caught by Yara rules.
Yeah.
I want to replug something really quick, only because there's a really cool sort of hands-on opportunity here for anybody that's interested. Earlier in the chat, I dropped a link to a blog post I wrote a little while back. What's cool about the blog post is it talks about some of these things, but there's a hands-on component, and what it is, it's a simple PowerShell script you can run, and it does nothing bad. You can look at it; it's super benign. But what it does is it pulls down like SSD and it'll do some tests. It'll say, okay, we're gonna copy this file, and then we're gonna copy it 10 more times, slightly modifying it each time, and then we're gonna run fuzzy hashes against all 10 of the copies. And then you get to sort of see like, okay, I can see how the hash sort of changed slightly, but I can also see very easily the similarities between them, even though the file has changed several times. And so if anybody wants to just like see what this looks like, that PowerShell script would take you 5 minutes to run.
Yeah, and one other thing that I want to touch on before I forget is something that we haven't talked about is outside of detection, it can also be great for just grouping malware. So like if you have an Intel team or you're cataloging malware, doing anything like that, it can be great for ingesting large sums of malware, putting them into groups and tracking them in that kind of a way, looking for maybe even feature differences if you see a big enough difference in um, the score.
So that brings up an interesting question. This just popped into my head, and it's fresh in my mind because I was recently working on a case management tool in Notion, but this is, I think, maybe I wouldn't call it a flaw, but an opportunity for improvement in probably many case management and Intel tools, right? We treat IOCs as just like concrete, variables, right? Like just you put it in there and that's what it is, and you're only looking for direct matches on it to do correlation. But with fuzzy hashes, it's not a direct match that I'm always looking for, right? It's a similar to, right? It's a likeness that I'm also interested in. And so I wonder if there are any case management systems, whether they're SOAR platforms or SIEMs, that can do that likeness, right? Instead of always looking for a direct match, because I might want to know if, for instance, in my SIEM, if I have a list of known bad SSD hashes or TLSH hashes, I don't need it to be an exact match before an alert should fire, right? Maybe I care about something within 5% similarity, right? David, is that a thing? Because I genuinely don't know.
Not that I know of.
Mm. Quick, hold on. I got to go to trademark, contact Gartner. I'm going to start a new quadrant here.
Yeah, for real. I mean, that would be, I'm sure you could probably do something like that. Yeah, I don't know. That would be interesting.
Yeah, it would be tricky though, because it wouldn't just be like a Levenstein thing. I mean, you'd have to understand the subcomponents of the hash to know, like, where do I gauge a similarity, or you'd have to have some sort of function on the back end that would use the hash. So like TLSH, you can use to take a hash and compare it against a list of hashes to compute the similarity percentage or what have you. But that would be an interesting project. Yeah.
I'm not going to pretend that I understand all of the math on how TLSH is calculated behind the scenes, but
Oh,
one of the things that it does, and I think where that could come into play in a similar style for what you're talking about, is it doesn't just do like a raw data versus raw data. So if you take one byte and move it, it doesn't just, calculate a new hash. It tries to group like binary data. And I'd guess if you're trying to do something like that with case management systems, you could probably do something similar, come up with a hashing algorithm that's a fuzzy hash that does like data and then says, hey, how similar are these IP addresses? Are they the same subnet? Maybe give certain weights and stuff to certain pieces
uh,
and come up with some sort of hash that, takes all of that into account.
Think of it somewhat, it's not to say, but I think of it somewhat similar to JA3, JA3S, that like take some invariant aspects, take the hash of the first 10 instructions of the first 10 functions in the binary, and those are unlikely to change even if some of the content does. That's not actually how it works, but it's a little bit less likely to change than the overall hash.
Yep.
yeah, speaking of JA3, probably in chat talking about the many different network side. Probably, where are you? I don't see you. Props. Tell us about some of the network magic, man.
Yeah, well,
Oh,
so something that I've been working on and I'm still testing privately is there was an old Bro plugin for fuzzy hashing that one of my colleagues at Corelight built that I have uh, been updated or had updated to more a Zeek version. So it's been Zeekified, I guess you could say. And something I'm still kind of testing, and this might not work performance-wise, so we'll see how it goes, but is how TLSH hashing can work with a Zeek script. So basically, there's already a plugin out there. I think it only works with older versions of Bro. I don't think it's been maintained until recently, but where it would just calculate those TLSH hashes and just add it to the files info of like a Zeek script. So like let's say you have Zeek in your network, um, just through a native Zeek script and Zeek plugin, you could be calculating the TLSH hashes of all the files that traverse your network. But if you have that, you could also conversely build a Zeek script that then takes those and then does that distance comparison and generates a Zeek notice if it sees a TLSH comparison or a TLSH match within a certain distance. And that's something that I'm actually working on internally and have in my own private lab. So hopefully the performance of that works as I'm hoping and expect. So fingers crossed, because that'll
How
be a
does
really
that how does that work with the encryption, calculating the hash of the file that goes through the network and through your Zeek sensor?
Yeah, so there's two things. A lot of you would be amazed at how much malware still crosses the wire in the clear. But there's also stuff like SMB traffic where a lot of it's still not encrypted, and you can just pull those files off and get that data that way. And there's just I think you would be surprised at how many files traverse your network in the clear, especially that might even be malicious. And
Mhm.
if you are one of the organizations that's lucky enough to have TLS like interception and decryption, oh man, it's really sweet.
Yeah, well, that I know, but I think I'm not sure if most of the people here or in general,
Yeah,
you needs a certain level of maturity to get that, and
yeah,
there's all of the privacy issue to that goes with it. But yeah,
network
yeah.
monitoring is expensive, especially to do it well. It is very expensive, and I think that the days of its usefulness are narrowing, and I'm not going to say coming to an end. I'm just saying they're narrowing, right?
I
Like,
I actually disagree with that. So
okay,
there was a CISA advisory. They had a red team kind of group or testing the end of last year that had a bunch of notes that came out. And one of the main takeaways that the red team came away with was an over reliance on EDR allowed their red team to just move around a lot easier. And one of the things, so uh, full transparency, I'm at Corelight now, which is a network security monitoring company. But
there it is.
yeah,
Just kidding.
but if you know if you heard me or spoke to me prior, I was at Target And I was always saying, I'll never leave Target. I have all the data, I have all these smart people, I have all the tools I could want. And one of the things that I noticed is whenever our red team would work at Target, they always managed to get on a system that either couldn't be monitored by an EDR, they killed the EDR, whatever it might be. And our network data and Strelka data was always the kind of first place that I personally would go, and saw an opportunity open up at Corelight. That's why I'm here now. So I think
Okay.
that so what I would say is I agree with you in the sense that for the longest time I thought that the network kind of sensor's role was kind of shrinking in necessariness for uh, uh, I guess a company, but I think as organizations have gotten that mature EDR deployment and as that's becoming more of the standard, I feel like that next kind of piece is the network portion coming back into play.
Well, David, so we're coming up on the end here, and Jeff very thoughtfully called out that he found your project for the TLSH extension for Lima Charlie. So if you want to take a couple minutes, talk about that. What is it? What kind of value does it bring?
Yeah, so basically, I created a TLSH extension. It's on the Lima Charlie marketplace now. It's called Celestial SH, which I thought was pretty clever. But basically, the idea is it takes all of the unique binaries that binlib ingests and takes that TLSH score that binlib so thankfully calculates, and then it does that distance comparison and generates an alert for you. So it takes a lot of that data that I've created in that public repo that I've made open source. But I also have a bunch of stuff that's not in there for the Lima Charlie extension that's malware related. So some of the things like Cobalt Strike, Brute Ratel, that kind of a thing. So any unique binary that's executed, DLLs, anything that's captured by binlib, shell scripts, yeah, like anything that's captured by that code identity will get hashed with a TLSH algorithm, and then my extension will do a comparison against like 100 known tools, and I get all of the different malware. I got all of the top 10 stuff on the new any.run report and TLSH hashes for them. So yeah.
So
Quick
what's go ahead,
quick
Jeff.
comment, sorry. I was curious as to, I know Metasploit when it generates binaries, because it's easy to focus on stuff that comes out of public tooling, but
Mhm.
there's enough polymorphism there that I generated file 00 through file 20 of the same payload, even though the overall file executable will be the same. And it was like 100 being the highest score, 0 being completely different binaries. It was like 45 to 55, which if you had to like say some threshold for start your threat hunting here and adjust, what threshold would you of similarity would you say is worthy of further examination?
Yeah, so I set the default on my app for 50. I think that's good for most organizations. I think if you're a larger organization, you're going to probably want to shrink that down. But anything below 50 is worth taking a look at for sure. It's still potential that you might get a false positive in there, but
Above 50, right? Because it's a higher match is closer binary, higher number is closer binary, right?
no,
Because
lower.
file,
So
yeah.
a zero, a score of distance 0 is a perfect match, and then the higher you get, the further the distance.
I was doing SS deep, not TLSH, so it's the opposite for SS deep. My bad. Okay.
Yep, no worries. Yep.
One's a percentage match, and then one is a distance. You
Yeah.
gotta love that.
TLSH does distance, SS deep does percentage match. Yep.
Yep.
Yes. Oh man, that's good time, right? Don't confuse those two.
Interestingly enough, and I'm trying to figure out how they do this. So if I ever figure it out, I'll let y'all know. But VirusTotal, if you use their TLSH stuff, and I think they might only show this on the private enterprise side, but it gives you a percentage difference score for the TLSH comparison. So I'm interested to see how they come up with that. My hunch is they're considering the score of 500 of being totally different, but I don't know that for sure.
Awesome. Well, man, perfect timing. That was a ton of awesome content. Thank you so much for joining us, David. We got a lot of good links in the chat here. If you didn't get a chance to copy those out, don't worry. They'll get cross-posted into Slack. So make sure you're in our Slack, slack.limacharlie.io, because we also give away a Defender Fridays t-shirt every week to one of you lucky attendees. So thank you so much for spending half an hour with us today. We'll see you same time, same place next week. Have a great rest of your day, folks. Take care.